Welcome to the Veritas Forum, engaging university students and faculty in discussions about life's hardest questions and the relevance of Jesus Christ to all of life.
Thank you, and it's great to be here. I just yesterday got in from Toronto where I was talking about the multiverse at a workshop and it was snowing. So I really appreciate the weather and appreciate the invitation. The topic tonight is the fine-tuning design argument, and as the subtitle says there, it's an argument from physics and cosmology for the divine creation of the cosmos. Typically, in the media, and a lot of people are saying this, but they say is that science has disproved religion, has disproved the existence of God. Richard Dawkins says things like this, a famous biologist and a famous atheist. Steven Weinberg, a very famous physicist, says the more we find out about the universe, the more meaningless it all seems. Well, tonight, what I'm going to show you is that actually when you look at the details of physics and cosmology, and I'll keep it at a popular level, that actually it strongly supports the existence of God. So that's what I'm going to launch into. What's the evidence I'm talking about? And then we'll be looking at the hypothesis of the existence of God as one explanation and the atheist alternatives to it. So let me begin. Okay, so I'm going to be arguing that the opposite of what these people claim is the case, that the area of fundamental physics, our discoveries, strongly support the existence of God. So what is this fine-tuning? In the last 50 years, you see up here, scientists have discovered that the universe is analogous to a biosphere. The basic structure of the universe is precisely set for the existence of life, particularly beings like our intelligent, conscious agents like ourselves. This is called, in the literature, the fine-tuning of the cosmos. So it's sort of analogous to this. Here, out in Arizona, if you drove, 8 hours or so, it'd probably be out there somewhere. I don't know exactly its location, but it's a biosphere that was constructed so that it could support life inside without anything coming in from the external environment. So people lived in there for a couple years and it had its own oxygen recycling system. It could grow its own plants and things like that. But it wasn't quite fine-tuned enough. It wasn't quite right, and in 2 years, toxins built up too much. And then people had to evacuate it. Now it's a tourist attraction. Okay? The universe is not like that. It is fine-tuned just right so that we can exist. Oops. Now, there's a key assumption in this argument, in what I call embodied conscious agents, which we're an example of, are the relevant kind of life, and such agents require stable, reproducible complexity to exist. There's 3 types of fine-tuning. The fine-tuning of the laws of nature. The fine-tuning, can everybody hear me okay? It's working? Okay. The fine-tuning of what's called the constants of physics. And the fine-tuning of the initial distribution of mass energy in the universe. So I'm going to go through each one of those and explain what they are. The easiest to understand will be the fine-tuning of the laws of nature. To say that the laws are fine-tuned means we have just the right set of laws in order for life to exist. I will consider 5 of around 14 examples. Oops. I'm not used to this power. Okay. The first one is gravity. What is the law of gravity? Well, the law of gravity says, and I won't do it, but it says if I let go of this, it will fall. Okay? And it implies that what it says is all masses attract each other. This is very important for there to be life. Let's imagine a world that did not have gravity. Let's say the universe, there was no universal attractive force. There wouldn't be any stars, and there wouldn't be any planets. All the universe would be is matter would be kind of uniformly distributed around the universe, and there'd be no place for life like us to form, and no planets, and there wouldn't be any energy sources. The stars serve as essential energy sources for life. They power plants, they power that ultimately we feed on, animals feed on, then we eat, and so they allow for beings like us to exist. So that's one example. Here's another example. The electromagnetic force, and first of all, explain what that is. The electromagnetic force is a combination of the electric and magnetic forces. And it was unified, these two forces. You've probably all heard of the electric and magnetic force. This was unified into one kind of force by James Clerk Maxwell in the 1800s. What would happen if there wasn't the electric and magnetic forces? Well, there would be, first of all, no atoms, and hence no life. There'd be nothing to hold the protons, the electrons around the nucleus. Okay, so the protons, positively charged, attract the electrons, and they keep them in orbit. So that allows for chemical bonding to occur, and so allows for the first building blocks of life. And actually, the next several examples I'll be looking at are the conditions for just having the building blocks of life. The existence of the electric force is one of those conditions. So it's not easy to get the right universe that has the building blocks for life. You have to have the proper conditions, planets and stars. Then you have to have the right building blocks and quite a few other things. The electromagnetic force also plays another role. And light is an electromagnetic radiation. So is the stuff, the transmissions from your cell phone. That's also an electromagnetic radiation. So it's an electromagnetic wave. And the electromagnetic force allows energy to move across space from the sun here to our planet. And so allows this whole process to occur. If you didn't have some means of moving the energy, once again, beings like us could not exist. So interestingly, this plays at least two different roles. Actually, it plays some more roles. So this is something I'll be stressing in another cases. Not only has the right laws, but if they're elegantly put together, often one law will play multiple roles. So it's a very well-designed system, if you will, very elegantly designed. So here's another. So we're asking about this building block. So we have the electrons and protons. We're getting the start of an atom. But we need more than that. We need more than this attractive force to have an atom. We also need something to hold the protons and neutrons together in the nucleus. Why? Well, here is protons. Protons are positively charged. As I hope we all have learned at some point, positive like charges repel each other, unlike charges attract each other. So there needs to be something else holding the nucleus together. When I ask my students this, most students don't know. It's like maybe 1 out of 30 knows the correct answer. What it is that holds the nucleus together. We need something, so we need something more than just this electric force. Well, scientists had to postulate that, and what they postulated is the strong nuclear force. This was me when I ran for the governorship of California many, many years ago. So here is the strong nuclear force. And you see me holding this together. But we're not done yet in forming an atom. That's not enough. We still need more of the right stuff in place. So if you think about an atom, the electrons, what keeps them in the same orbital? What actually happens is if the electron is moving around, electromagnetic waves are produced by electrons that aren't going at the same velocity in a straight line. So if you cause electrons to go in a circle, they will produce an electromagnetic wave, any kind of acceleration of the electron. Well, that's what happens in your cell phone. Electrons move back and forth real fast, and you get the transmission coming out. So here, there was another, when scientists first hypothesized the atom, there was another issue that had to be faced. Well, what keeps the electrons from instantly going and crashing into the nucleus? So in 1913, Niels Bohr famously hypothesized the principle of quantization that dictated that electrons occupy fixed orbitals. So there has to be this next principle in place, the principle of quantization, to have atoms. You think you might be done there. Now we've finally got our atom, and we finally got our basic building block that we can get life from. No, you're not done yet. There's still some other missing ingredient. For one thing, what will happen, if you drop things, they want to fall to the lowest level. And if you put something like a ball on a slide, it will fall to the lowest level. Well, that's what these electrons would do. Why don't they just all fall, which is what you would expect, into the lowest orbital? And then you wouldn't have any complex chemistry, because complex chemistry depends on these outer shell electrons. That's what makes the atom have some complexity, so you can have interesting atoms that can get into chemical combination with each other. So there needs to be another principle in place, and that's the principle of quantization. I just made the point I just made here, that this is what would happen if you didn't have an additional principle. So the solution is what's called the Pauli exclusion principle. How many have heard of that principle before? Okay, quite a few people. This principle comes from a deeper principle in quantum mechanics, and it states that its implication is that no more than 2 electrons can occupy any orbital. And so it helps keep this from happening, all the electrons falling into the lowest orbital. And it was first proposed by Wolfgang Pauli in 1925. It also plays another very interesting role. And there was quite a few of these things that were actually deeply meaningful to me. I could feel them viscerally. Well, quite a few years ago, as I was researching this topic, I found out the Pauli exclusion principle, without it, and it was proven in the 1960s, that without it, all matter would collapse in on itself. So the very solidity of matter you have here is the result of the Pauli exclusion principle. Some of you might have heard, and it's true, most of the material we have here is just empty space. It's like maybe 1 part in a trillion is occupied by the particles. And what keeps it all from collapsing in on itself is the Pauli exclusion principle. So it's quite mysterious how this thing is supposed to work. It's a rule that's in nature. There's not really any, it comes from a deeper rule, but that's just another rule that says this is how things are to work. So when I'd walk around like this, it would just feel like such a miracle, and still does, that we can walk around at all, that things from moment to moment continue existing. So I felt this whole thing viscerally. There's quite a few other cases I did. My wife kind of testified to this. Okay, it was like a religious experience for me when I found out about this stuff. And this also illustrates another interesting point, is often a single principle plays multiple roles. It makes complex chemistries, but it also allows for the solidity of matter. So there's an elegance about it, one thing doing multiple things. So precisely the right laws are needed for highly complex life to develop, and I've listed 5 here. There's about 14 of these, so I've given you kind of just a few of them. So that's the fine-tuning of the laws of nature. Another kind of fine-tuning is what's called the fine-tuning of the constants of physics, or maybe a better name for it is the fine-tuning of the parameters of physics, but this is what it often goes under. So what is a constant of physics, where it's a fundamental numbers that occurs in the laws of physics. And these must be extraordinarily precisely set for life to exist. Well, let me give an example of a constant, and that's Newton's law of gravity. And let's just think about this for a second. Let's suppose I were like Q in Star Trek The Next Generation I like, which is kind of this real powerful being, could do all kind of thing. And I made a universe that said, well, masses attract each other. And Q's wife, I can imagine her interrupting and say, well, that's not good enough. You have to say how much they are to attract each other. If I just said attract each other, that doesn't tell me how fast this is supposed to fall. I have to specify an amount. That's what these numbers do, these constants. So in Newton's law of gravity, there's this constant, g, called the gravitational constant. And this is Newton's law. The force between any two masses, let's say me, in the center of gravity of the Earth, that force is equal to this number, and here it is written out in its units, times the first mass, my mass, times the second mass, the mass of the Earth, divided by the distance between me and the center of the Earth squared. Okay, that gives me the force. So if I were able to, let's say, double G, I weigh 153 pounds right now. That's how much force I exert. Pounds is actually a measure of force. If I double G and I went to the bathroom scale, I'd weigh 306 pounds. If I made G 1/2, I'd weigh 76.5 pounds. So you can see G determines the force. And let me give from Dr. Collins a piece of advice for those who want to lose weight. If you want to lose weight, don't try changing G. You need to try changing M. Okay? So that's my medical advice for tonight. So how fine-tuned is the strength of gravity given by G? Well, to ask the fine-tuning question, first you have to have an overarching scale. Just like how much do I have to tune a radio dial? I have to ask, well, how big is the dial? So that's the first question we're going to address. Well, here there are 4 forces that we know of in nature. And they're each governed by a respective constant. And there's a dimensionless way of expressing these constants standardly used in physics. It's really, it can be thought of as the force between 2 protons in the nucleus. And the protons in the nucleus are being held together, or they have a gravitational force between them. They have an electromagnetic force trying to repel them. And they have the strong nuclear force, as we saw in a previous slide, holding them together. Well, if you look at the strength of those various forces between those 2 protons, the strong nuclear force, if you had a ruler here, the strong nuclear force would be 10 to the 40th times the current strength of gravity. What is 10 to the 40th? That's 1 followed by 40 zeros. That is 10,000 billion, 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 billion times the strength of gravity. So to get a kind of an imaginative grip on that, let's suppose you had a ruler extended all the way from across the universe, which is about the visible universe, about 15 billion light years in radius. A light year is the distance light travels in a year. Light travels at 186,000 miles a second. There's approximately 86,000 seconds in a day. And multiply that by 365, and then multiply that by 15 billion. That's how long the ruler is. And if you were to put those on the ruler, the strength of gravity would be right in about the 1 trillionth of an inch here, and the strength of the strong nuclear force would be set way over there. So that's the kind of scale we're looking at. And I didn't talk about the weak force. That's just another force. It'd take a little bit more to explain what that is. Okay, and I already just gave this my ruler representation. 15 billion light years, trillionth of an inch. That's where the 2 would be. Now, we do some thought experiments here. Let's suppose one increased the strength of gravity by 1 part in 10 to the 34th of the range of force strength. It's a billion-fold increase, but it's nothing compared to that huge ruler. If that were the case, then even single-celled organisms would be crushed. Like a planet like ours would be a billion times stronger. And you could only have life on a planet maybe a little over 100 feet in diameter, where you couldn't sustain an ecosystem. You just couldn't get, basically you couldn't get any world in that universe with intelligent life like us. It would be effectively, for our kind of life, any kind of life that could be conscious and engage with each other, it would be a dead world with regard to that. So that's the result of gravity being too strong. In fact, now this is more calculations I've done since that previous slide. If G were increased by a mere 64-fold, the gravitational force on the surface of any planet that could retain an atmosphere would be at least 4 times as large. A 400-fold increase in G would result in any such planet having a surface force at least 10 times as large. So it would be far less ideal. And then if you went small in the other direction, a lot of other effects would occur. One, your hydrologic cycle that brings water into land would be seriously compromised. And there's a bunch of other effects. In effect, this is way overdetermined, actually. The problems you run into are manifold more than these, like 2 other problems you run into going each direction. So there's multiple reasons why it has to be in this very teeny region. So the strength of gravity must fall in an exceedingly narrow range of values compared to the total range of force strengths for beings like us to exist. So if you thought of a radio dial here and is stretched across the universe, anybody remember these? Okay. This is how they used to look when I grew up. Okay, so it have to be tuned in to the right. I think out in the West, they always go by K. I think the radio station would have to be K-Life. It has to be tuned just the right little teeny area, K-Life, in order to have a universe for life. If there's anywhere else, it wouldn't be possible to have life. So that's one really extensive fine-tuning, like a fine-tuning of 1 part in around 10 to the 40th is the fine-tuning of the constant of gravity. Just an enormously small number. Here's the one that's been the most discussed in the literature, the cosmological constant. It's actually better referred to as the dark energy density. And some of you have heard of dark energy density. It must be in an extremely narrow range around 0. If it isn't, the universe would either collapse in on itself or it would expand too rapidly for galaxies and stars to form. How fine-tuned must it be? It's usually estimated to be fine-tuned to 1 part in 10 to the 120th power of its natural range of values, an extreme fine-tuning. So there's just this huge cosmology literature and trying to figure out how we could get around this kind of fine-tuning. So if you looked at like the astrophysics website archive, there'd be lots and lots of articles that have been printed in the last 30 years, and no one's really resolved the issue scientifically, at least. So it's an unimaginably precise degree of fine-tuning for there to be life. So once again, if you did the WK radio station analogy, it'd be an extremely narrow range. So there's many more constants of physics that have to be adjusted just right. I've given you 2 examples here. And this is widely recognized. For example, Stephen Hawking, who's no friend of theism, he says the remarkable fact is that the values of these numbers, referring to the constants of physics, seem to have been very finely adjusted to make possible the development of life. And Dennis Guillemot, former director of Cambridge University Observatories, if you change a little bit the laws of nature, change a little bit the constants of nature, he says, it is very likely that intelligent life would not have been able to develop. So that's the fine-tuning. We've done the laws and the constants. The final one is really the biggest one of them all. And that's the initial distribution of mass energy. According to standard cosmology, and we're assuming standard cosmology here for now. If you assume younger creationism, you already believe in God. Okay? So I'm addressing what's on common ground for people in the sciences, which is standard cosmology. The universe, the visible universe we saw, as you wind back in the past, 13.7 billion years, it was condensed back into a very, very small region, less than the size of a golf ball. Okay, and it's all blown out and expanded since then. And there's very good evidence for this theory. But here I want to point out something more about it. This arrangement of mass energy had to be exactly, very, very precisely right in order to get galaxies, planets, and eventually us to exist. And kind of an analogy here is the zygote analogy. Even though you might look at this from the outside and it seems to be just a blob of protoplasm, kind of undifferentiated, you get that microscope, you see it has very, very highly precise structure. And if it didn't, none of us would be here. Okay? There'd be no animal and plant life. So likewise, even though you might not see it by looking from the outside, it's just like a bunch of energy there. It actually has to be very, very precisely structured from a physics perspective. How precise must it be? Well, ask Roger Penrose. He's one of Britain's leading theoretical physicists. And the calculation here is actually fairly easy. It comes off a standard formula. But he's really emphasized his point a lot. And here is a diagram out of his book, The Emperor's New Mind. It has to be fine-tuned. Phase space is the space of possibilities that physicists use. They call it phase space. So he says, and I don't know whether he believes in God or not. If he does, he doesn't really talk much about it. So he just uses the idea of God as a way of illustrating the point. It's not to say he actually believes in God. So he says, in order to produce a universe resembling the one in which we live that actually can have life like ours, the creator, he says, would have had to aim for an absurdly teeny volume of the space of possibilities. How teeny? Well, it's 1 part in 10 to the 10 to the 123rd power. So that's 1 here followed by 123 zeros. And then whatever number that is, follow that by 1 followed by that many zeros. And that is just, you can't even imagine how small that is. So I give a diagram here. It's far, far more precise than this. If you were across the universe and you threw a dart, you were going to try to hit a single penny, the precision required for that would just be peanuts. Just nothing, absolutely nothing compared to this other precision. So once again, there's no real explanation for how this could came about. It just you have to assume that at the beginning of the universe, this very precise structure. So let me just recap here. So you've got 3 kinds of fine-tuning: the fine-tuning of the laws of physics, the fine-tuning of the constants of physics, the fine-tuning of the initial conditions of the universe. And there's one other kind of fine-tune. This is what I really got excited about in the last 2 years, is the universe is, and I'm not going to really go through it in detail, I don't have time to, but the universe is not only fine-tuned for life, but also that we can discover the universe. Precisely said, if things were slightly different, we wouldn't be able to discover it and we wouldn't be able to develop technology. If like one parameter were slightly different, you couldn't have open wood fires, and so we never would have forged metal. And move it a different direction, light microscopes lose resolving power. There's just a whole bunch of things like that our technological civilization is only possible because of another set of precise adjustments and things. So it's a whole different area of fine-tuning. So here's many years ago when I first started thinking about this, I like to use diagrams in class, and one of my students drew this for me. So and I use circular dials to think about the fine-tuning. Dials perfectly set, life can exist. Dials imperfectly set, there's no life. And this presents what they call a cumulative case argument for this fine-tuning. It's not just one piece of evidence. It's many, many, many different pieces of evidence point to the same thing. Like if we found some natural way, let's say, of explaining the fine-tuning of the cosmological constant, you would still have all the fine-tuning of the laws, all the fine-tuning of the other constants, and the fine-tuning of the initial conditions of the universe. So you have many pieces of evidence pointing to the same thing, much like if in a murder trial, if the DNA evidence, the fingerprint evidence, the evidence from witnesses, and you have motives written down, they all point to the defendant as guilty. The jury is going to say guilty beyond a reasonable doubt. It's the same sort of thing happening here. The universe must have an enormously precise structure for life. It's a cumulative case argument for that. Okay, these are the optional slides. I'm going to click over them. Those are for the stuff on discoverability and technology. This one is actually, I drew a prediction out of it and turned out to be true from that idea. So I'll go on. I go on to the next. Is there something funny? Oh, this is the diagram? Okay. To many people, the evidence of fine-tuning immediately suggests the divine creation as the explanation. So here is William Blake's Ancient of Days, and here it's imagined fine-tuning the universe. Of course, I wouldn't imagine it that crudely and anthropomorphically, but it's good to put on the slide up here. So that's the idea. So that's one explanation. Now, even non-theists see that as initially what it seems to be. If you just look at the universe, contrary to what Steven Weinberg says, it seems like it is designed. Whether or not you believe it's designed or not, it seems that way. So here's theoretical physicist Paul Davies, now at the Arizona State University. He's written a lot of popular books on this subject. He says in one of his books, many of his books, the impression of design is overwhelming when you look at it. It all looks so well put together. Fred Hoyle, who was an atheist, said this. He said when he discovered one of the very first cases of fine-tuning, he said a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics and there are no blind forces in nature. As we'll see, he didn't accept that explanation but had an alternative, which is effectively the many-universes hypothesis. So it really looks like there is this fundamental design in the universe. So what are all the alternatives to this hypothesis? Well, there's two big alternatives. Some just say, well, it's a lucky accident. We were just enormously lucky. And that's all there is to be said about it. But most people, or a lot of people, find that very hard to believe. So here is like an ink spill. Let's say, would you ever accept that this was just an ink spill if you found this on your desk? No. Or if you went to your roommate's refrigerator and you found in the back, growing in the mold that's back there, okay. And if you found this image, you wouldn't just think it happened by accident. You'd think your roommate, arranged was maybe a biology major and was doing an experiment back there. Because not only is it extraordinarily improbable, but it's highly meaningful. Those two, when you get those two combinations going together. There's another sort of analysis of this. I'm going to leave it at that. That's why many people reject that. So they look for something else. And so this is in the cosmologists or physicists that are atheists, like Stephen Hawking, this is the explanation they go for. So this is the major alternative explanation. It's called the multiverse or many universes hypothesis. I was just at a conference in Toronto I got back very late last night from. And that was the whole workshop was on this issue of the multiverse hypothesis. And I gave a talk there. It was on how theism relates to the multi-universe hypothesis. So what is the hypothesis? This is the hypothesis according to which there are an enormous number of universes with different initial conditions, values for the constants, and even the laws of physics. So eventually, just like if you produced enough lottery tickets, even though it's maybe 1 in 10 million chance of a particular the winning number coming up, eventually, if you produce enough tickets, it will come up, just by probability. So the idea here is that humans are winners of the cosmic lottery. And when it comes up, then humans evolve. And then they look back and say, wow, weren't we lucky? But it was just, unbeknownst to them, just a result of this chance production of many, many, many universes. So this is widely advocated. Max Tegmark, professor at MIT, Sir Martin Rees, Stephen Hawking, for instance, all advocate this hypothesis. Here's several books on it. Here, these are by Stanford physicists. Here was a collection by Bernard Carr. I have an article in this on a theistic interpretation of the idea. And here's a recent book by Stephen Hawking. Actually, a very poorly argued book, but that's the one that is very poorly argued. It needed. I don't know if it's Stephen Hawking's fault or was his co-editor, but that promotes the multiverse hypothesis. And it comes in two major versions. Here's one version that a few people have advocated. They say every possible reality exists. There's a reality in which I'm president of the United States. The Narnia tales, they're true in some reality, like Middle Earth, but there's a reality which Middle Earth, every possibility exists. So of course ours is going to exist in this hypothesis. This is not widely advocated. Rather, what's widely advocated is this version. There's some physical process out there that generates universes, just by chance. And every time it generates a universe, so this is my caricature of it, okay, my cartoon image of it. So it's pumping out universes onto a conveyor belt, and it adjusts the law, some of the constants and to some extent the laws and the initial conditions by chance. And eventually, one of the universes that pops up is just right for life, and voila, here we are. I mean, it's generating a horrendous number of universes, like 10 to the 500 power or something, one followed by 500 zeros or even more. To explain entropy, it'd have to be vastly more. So one version of this is called inflationary cosmology. It's speculative, but there's some evidence for inflation. And in that view, these universes would naturally arise. Doesn't require it, but you can make sense of this mini-universe hypothesis according to that view. So you can imagine this view is like this. They imagine there's a pre-space, and these universes bubble up out of the pre-space at random. And so you can imagine like an ocean full of soap. You look out at the Pacific and somebody filled it all with soap. And then soap bubbles are coming up, and those are universes. But the ocean keeps expanding at an enormous rate, so the bubbles never collide with each other. So that's the idea. And I said this is one of the leading speculations in cosmology for now the last 30 years. Now, there's various possible theistic responses to this. Some theists say, well, it takes more faith to believe in this than to believe in God. Now, everybody to go this route is jumping beyond what we see, far beyond what we see in their speculations. So they can no longer accuse the theist of doing that and saying, I'm just staying with what we see. No, they're hugely speculating. Some say, well, where did the universe generator come from? Universe generator would need to be well constructed to produce a single life-sustaining universe. And this does not explain the optimality of the universe for science and technology. And we could have arisen in a universe that was not optimal at all, and it seems to be optimal for that. So observers could have arisen. So and that's more, I'd have to go into that and why it doesn't explain that, but more time than I have. So I'm going to sort of go into just illustrating this. The third response we'll focus on. I'll just give an analogy, and you can work this out in more detail actually without the analogy, but it's a bread machine. Bread machine produces loaves of bread, okay? So here's an analogy here. Here's a bread machine. It must be precisely constructed and correctly operated to produce decent loaves of bread. Further, the ingredients must be right, the amount of yeast, gluten, water, etc. Otherwise, loaves come out like hockey pucks. Rebecca remembers that happening. Here, Rebecca, here's my loaf of bread. I forgot to put the yeast in. Okay? I was absent-minded thinking about a philosophical problem. Actually, and we still have the bread machine, and it's been defunct for many years. I don't know why it still sits there, but it still sits there in the kitchen with stuff on it. Now, you only got rid of it. Okay, good. But you didn't get rid of it? Okay. So it has to be properly constructed. All the mechanisms have to work just right. That's like the laws of nature. They have to be just right in order to produce even one universe. And that's what I'll illustrate next. This is actually a true trademark. Okay? And you know this equipment you buy from that company, you know it's good. See, because it's got the right name, well built. So the multi-universe generator has to be well built, precisely constructed to produce even one life-sustaining universe. It cannot just be, randomly put together. And I've precisely shown this in the for the case that's commonly advocated, the inflationary superstring model has to have just the right laws. Actually, it's more than this. I found more than this after looking at it later. But a set of just the right, finely adjusted laws in order to produce one life-sustaining universe. So it just kicks the problem up one level. And that was published in one of the books, the Theism Multiverse book that I showed by Cambridge University Press, showed a little while ago. So it just kicks the fine-tuning up one level. Who or what finally adjusted the multiverse generator? So here's the conclusion. The universe generator hypothesis does not significantly undercut the fine-tuning argument. But although theism is compatible with the mini-universe, maybe God created, maybe it was more elegant, just like there's many, many dead planets in our universe, and then there's ours. Maybe God created a mini-universe generator, so that's a possibility. But you would still need some designer of it. So let me look at the overall summary here. There's three responses to the fine-tuning evidence: theism, multiverse hypothesis, brute fact, chance hypothesis. Against 2, multiverse generator requires design. Against 3, because life is special, it is hard to believe that a universe just occurred by chance, as that an ink spill, even much, much harder actually, I'd say, that an ink spill gave rise to the picture of Abraham Lincoln. There's a different way of formulating that, but that would be in a question and answer session. If a certain question comes up, I could show that. So here you can simply type my name into Google. You'll get this. A good place to look if you want to see how the atheist responds to this. There's the first online book, The Theism and Atheism Debating Each Other. And that's here at infidels.org. I still have a copy of my check from infidels.org for writing this article. Okay. Well, here's additional slides. So these I go to that nicely explain various questions that typically arise. Like there's a who designed God question that very often arise, especially by people who have read Richard Dawkins or others. So that's it for the main presentation. So open it up to question and answers then. Okay, you can field them and all.
Okay, so we have about 25 minutes for questions and answers.
Thanks, Dr. Collins. In your published work, you phrase the argument in terms of epistemic probability.
Right.
I was wondering what the reason was for that and why you do it that way as opposed to a deductive argument like what William Lane Craig does, and what you think that adds to the argument or how it strengthens it.
Okay, the inductive kind of argument you're referring to is a best explanation kind of argument. It's very difficult to make that rigorous, and I was trying to make things rigorous. So if you go to God as the best explanation, then the atheist will turn around and say, well, what's your conception of God? In order to make that work, you have to be able to give a nice, clean explanation of what God is and then show how God explains the phenomena. But God is when we think of God, if you look in the philosophical literature, it's hard to understand exactly what God is. We can sort of talk about God, but to precisely explain how God operates and how God would explain that, I think is maybe beyond our capability, so I don't want to pursue that kind of method. And then you would have to compare that kind of explanation, when you say it's the best, with a scientific explanation. But it's a very different kind of explanation, so I think to some extent you're comparing apples and oranges. So I prefer to do it by the epistemic probability. Then it's a confirmation claim, and the way I formulate it, now you didn't see it here, but the way I actually formulate it is that it's much more, under the God hypothesis, the fine-tuning is vastly more probable than the not God hypothesis. So therefore, the fine-tuning evidence strongly offers strong evidence for the God hypothesis over the alternative. And so I see it as offering evidence. I don't see it as proving the existence of God. So I think to do that, you would have to have a nice, clean way of spelling out in detail the God hypothesis, and I think that's problematic.
Hi, thank you for coming. I just had a question about the theistic responses, or the atheistic responses, to fine-tuning argument. And I've seen online and stuff, the theistic responses to the atheistic response,
Right, okay.
I guess it would be. But, so I was reading something about Boltzmann brains or something, and how the most likely universe that could pop into existence would be just a single brain that would pop into existence and observe the universe for a couple seconds and just go out. And that would disconfirm in some way the atheistic response. And then there were other arguments against the multiverse hypothesis, because I think it was Roger Penrose as well who was saying, well, it's more probable that the entire solar system would come into existence randomly out of the collision of some particles than this fine-tuning. And I just wanted to know what
That's a very important objection. So this centers around the initial mass distribution of energy in the universe. And here's an example: if monkeys were typing on a typewriter, let's say, it'd be vastly, and you had all the monkeys you wanted, and eventually they would produce a meaningful sentence and occasionally a meaningful paragraph. And if you had enough monkeys, occasionally Shakespeare. But it would be vastly, vastly, vastly more probable for them to produce a meaningful sentence or a meaningful paragraph than the whole Shakespeare. It's or if you had 100 coins lined up and you shook them, and let's say it'd be vastly more probable to get, let's say, 5 coins in a row of heads somewhere. In fact, that'd be near probability 1 for that to happen, than for them all to come up heads. So the idea is if the universe, the arrangement of mass energy were just at random, it'd be vastly more likely for a small region of order to occur, enough for intelligent beings like us to pop into existence. Usually they're materialists, so they think that we're just brains, physical objects. Almost always they're materialists. And so it'd be vastly more likely for this brain to form just by a random fluctuation and suddenly have consciousness and then pop out of existence than for us to experience a world where we're interacting with other people. And so the fact that we're in a world where we can interact with other people, that would be expected under theism. God's not going to produce these isolated brains that pop into existence. But what would be expected under atheism is this is vastly more probable, just like in the monkeys typing on a typewriter, is simply this what's called a Boltzmann brain. So it has a huge difficulty in explaining the fine-tuning. I have an article in which I've extended that analysis and showed it runs into the same difficulty with other of the constants of physics. It's not just restricted to entropy. So it's another big problem with the atheistic explanation of this.
Okay, I had a number of questions, but the first I'll just ask one is, it seems like you're calculating, and I could be wrong, the probability of, or the unlikelihood of the existence of life by changing individual factors, right? Like, okay, so if gravity were different something, then that would have an effect on the electrical field or some other factor. But it seems like all of those factors might be different and that they could occur in such a way that a different kind of life, right, could occur. Do you see what I'm
Yeah, I
I'm
see what
saying?
you're saying.
So then that makes me think that it's really not very improbable that any kind of life occur. It's just that our kind of life occur. And that if that's what you're saying, it just seems like, oh, well, for our kind of life to occur, which is very specific, then there have to be these very specific conditions. But that doesn't seem to require an explanation of creation or design. That just seems to be like, oh, well, things could have been otherwise. There could have been other life, but not our life, because our life can only exist with X, Y, and Z.
Right, I understand the objection.
Okay.
So it depends on how big of a range you're looking at. If you had totally different law structures, who knows what's going to happen? And I can address that. Within the kind of law structure we have, where there's particles and atoms being held together and things like that, and if you look at the constants, you really are restricted to carbon-based life. You can't get, you can't use silicon. It just doesn't have nearly the right properties. So there's a lot of properties of carbon that allow this complexity to form. And in other cases of the fine-tuning, you won't get any complexity at all. Like if, let's say you didn't have the strong nuclear force, or it was too small, atoms would come apart. The nuclei, more than 2 protons couldn't be held. So the protons would fly off. All you would get is hydrogen. Contrary, and I'm a big Star Trek fan, contrary to what you see in Star Trek, you cannot get stable, reproducible complexity and hence intelligent life that can interact with each other out of hydrogen gas. It's not going to happen. So that's all you would have. So, or if the cosmological constant were too large, you wouldn't get stars, you wouldn't get planets, you would have uniform distribution of matter. So on very simple considerations, you wouldn't have be able to get life. So the kind of considerations I'm looking at are very, very general. Now, if you go somewhere way off somewhere in some very different law structure, then maybe there is a place you can get life. And there, I'll give, I have that addressed here. That is the second part of how this thing goes. I have it under the other, do I just, it should be, why isn't it, I should be able to go directly there. It's not allowing me to. I did before. Or maybe I need, oh, here it is. It's on this one. There we go. Okay. Nope, I hit the wrong one. Sorry. Oops, I got used to using this. Okay, it's bringing me back. I don't know why this is not working. It's not working at this one. Okay, I'll have to just do it by hand. If it doesn't go to the correct place this time, nope, it's not going. I don't know why it's not. It might be because it's on a Mac. Is it the same? What's that? Well, that wasn't the right objection. Well, let me just do it by hand. I'll just do it in the air here. I do have these things, so let me just do it this way. Let's suppose you had on the screen here, there's this huge board that you couldn't see, a dartboard. And there was a big circle here that was illuminated by a spotlight. The rest of it you can't see. And on a teeny, teeny bullseye, and you're standing there and you watch, and a dart comes in and hits the bullseye. And it was a teeny, teeny bullseye. I mean, 1/1,000,000th the size of that illuminated region. What would you say? You'd say it was somebody aimed at, because in the region you can look at, there's no other bullseyes. Okay, so it's a very, very small part of the region that you can look at. Shine. There might be other bullseyes elsewhere, but that doesn't matter. You don't know. What matters is it's very small to the region you can see. So that's the response to that one. Okay.
A conceptually simple question, I think.
Mm-hmm.
The first three speakers really had stuff that was way over my head. So we got this multiverse here, and I'm simply wondering, well, if we have this random generator that's spitting out a bunch of universes, presumably at a, I don't know, steady rate or some rate, what happens to them all? Like, where are all the different bubbles?
Well, they're in causally disconnected regions of space that we can't see. There's probably a lot more space probably a lot more space in our universe. It's probably a lot larger than the visible universe. They call that the cosmological horizon. That there's only so far you can see. Light cannot get to us beyond those regions. So those bubbles are beyond the cosmological horizon, farther than we could ever see. No, they can't really affect us at all. So you don't have to worry about, space aliens coming from one of them. Yeah.
Hello. Like Doug, the other questions are kind of over my head too, so hopefully this one's a little more graspable. How can one who claims God to always have existed, that a designer has simply, that there's no more fine-tuning beyond this creator, how can those claim that a multiverse generator hasn't always existed as well? That there is no fine-tuning beyond the multiverse generator?
Okay, there's one question, not to get into the cosmological argument. Could the multiverse generator have just always existed? And that's a particular version of the cosmological argument that Bill Craig has advocated that, the Kalam cosmological argument. And then he says, well, you can't really make sense of that in current cosmology, therefore you need something, the universe couldn't be eternal. He's right that it's really hard to make sense of even an eternal multiverse generated in current cosmology, therefore God's the explanation. This is not that kind of argument. So I'm not arguing, I'm not focusing on that, you need something that existed eternally. Maybe it could have existed eternally, let's say, but it would need to be very finely adjusted in order for life to occur.
Would, in that case, a non-theist believe that the multiverse machine is indeed more fine-tunable, or what would the
It just
theist
is. It just exists as a brute fact in being finely adjusted for the existence of life. Now, there is a kind of objection in the neighborhood, and that when God have to be finely adjusted. And so doesn't the theist have the same problem? That's the who designed God objection. And unfortunately, some reason can't get to those slides here, but I'll just say what the response to that is. So the argument is like this, is that, well, when the designer have to be more complex than what is designed. And if that was right, if you had an purely anthropomorphic designer, let's say that a kind of being that was in a human being and in a body, like Mormons believe in, that's the kind of designer they believe in, then you would really have a problem, because then you've just kicked it up. Who designed that super being's brain and body? Okay? But God has never been conceived of that way. God has always been conceived of as either absolutely simple, there's a whole tradition of that, for entirely independent reasons, or very, very simple. God doesn't have arbitrary boundaries inside. It's not like a watch, where you look inside and there's a material boundary between this and this, especially if it's old-fashioned with gears and things. But God has attributes, but the essential attributes of God are infinite. There's no boundaries in them. And so that's been, throughout the Christian tradition, God has been thought to be this being, unbounded being, and hence doesn't need any kind of fine-tuning. Now, some people have said, well, you can't make sense of that idea of God. It's not logically possible. But and there's a real issue there. But it's a trade-off between thinking there is such a being, even though we can't quite make sense within our own finite understanding exactly how that being could exist, versus accepting that all this stuff by chance existed fine-tuned to 1 part in 10 to the 123rd. So I find many people find the one far more unbelievable than the other. And in any case, this new evidence now has put the atheist on the defensive. It's like new dirt we found against that hypothesis. If you think in I have a political analogy for this. You have 2 candidates, and you're unsure before about one, and then you find terrible new dirt on one of them. Even you might be unsure about the other one now, you're going to vote for the other one if you're forced to vote. Okay, so you can think of it like that, and you can get around that kind of problem. Does that help? I know I may went beyond your question, but it was that's what your question really leads to.
Yeah, I think that's a sufficient answer for me. Thank you very much.
Hello. So this is kind of a poorly constructed and hastily constructed question, but with regard to the fine-tuning of the physical laws, it seems to me that when we look at like quantum electrodynamics or in quantum field theory, that a lot of the considered theories are just simply logically impossible. They lead to like infinities. And with regard to like the exclusion principle, which is derived from identical particles, that seems to be something that either is true or isn't true. 50-50. Either we can tell certain particles apart, or we can't. And so it seems that the fine tuning may not be as finely tuned, and that in addition to that, far out theories on the physical laws may just be beyond our epistemic sphere, what we can know and discuss.
Okay, I want to just say about your laws, and I won't explain what quantum electrodynamics is for people. But what you're saying is sometimes there's constraints on what are coherent laws of physics. So what people had pursued in the past, what they called grand unified theory, where the hope was just by kind of these kind of constraints, you could get one sort of law structure that would yield everything else. But then, as Bernard Carr and Martin Rees have pointed out, is that it would still be completely amazing that just the law structure that was allowed by these constraints was such that the only structure was one that gave just the right value among 1 and 10 to the 10 to the 123rd power. It yielded that structure versus all the others. So you've just kicked the issue back one level to the law structure itself. Why that law structure would have to be enormously fine-tuned to entail just the right values for the constants.
Thank you.
Hello. Actually, a fairly similar question. The argument, I take it to rest on a cumulative case, given the various laws and constants necessary for life. But explaining one theory, like he said, would be easier than explaining multiple. So what would become of the argument had, say, Einstein and his contemporaries succeeded in positing a unified theory of, general relativity, quantum mechanics, and that sort of thing?
If they hypothesized, then you would, I think it would even further support the creator, because I actually think God would do things in the most elegant way. So if God could ingeniously construct a law structure that actually entailed the right values for the constants of physics, that would be the most elegant way of proceeding. So I don't necessarily imagine God has reached down and fine-tuned them independently. But then of all the other possible law structures you could imagine, it would be amazing that you just had the one that forced the right values for the constants.
Hello. As a resident of Toronto, I'd like to officially apologize to you for the weather you experienced yesterday. Professor William Lane Craig of Talbot Theological Seminary recently on his radio show said that he believes that the creation movement, the creation science movement, to be an embarrassment to the advancement of the gospel in the 21st century. And he laid it primarily at the feet of people such as Kent Hovind, Ray Comfort, and Ken Ham of Creation Ministries. And I would like to ask you, this is more like your personal opinion, if you could sit down with those fellas, what would you say to them? Not about them personally or their inability to pay their taxes on time, but I mean more of their lack of vision outside of their own creation view, their own cosmology, and their unwillingness to accept the fact that there are believers such as myself who do not hold a young earth creation position cosmologically, but do still have the open-mindedness to share gospel with those
Right.
people who don't agree with me.
Well, I would say a couple things. One, I would say it's ultimately all truth is God's truth, so we don't have any fear of the truth. God created human reasoning capacity, so we don't have any fear, shouldn't have any fear of following a reason to where it leads. And it's not our business to try to persuade people of the truth of Christianity or the gospel. It's our business to be as careful as we can, objective as we can, engage in civil dialogue with others, to let the truth come out on its own. It's perfectly capable of doing that. God is in control. We're not in control. We just do our job, which is being as honest as possible intellectually. And we can say, well, this is how I see it. That's fine. And trying to lay the data out. It's not my fault if some of the evidence looks against my theory or against what I take to be the Bible saying. That's not my doing. I have to be honest and say, this is how the evidence looks at this point. That's God's job.
Hi there. You mentioned the materialist, worldview, or not worldview, but that science takes in explaining just about everything we know.
Mm-hmm.
Has, since, or for the past several hundred years,
Right.
since, we got away from church and state and the division of the two.
Mm-hmm.
And I guess the current matter over mind perspective
Mm-hmm.
that we take, I guess knowing full well there's a gap between the two as opposed to a mind over matter,
Mm-hmm.
or at least, for God's sake, to put it on the table, at least, an equal perspective, so to
Okay.
speak. So you do not see consciousness as that missing link.
Well, I
between
see
the two.
consciousness as a huge problem for materialists.
Right.
An enormous problem. So myself, I don't think consciousness can be accounted for by matter. And I think they have to go to absurd lengths to try to do that.
And
But that's a different set of arguments. Actually, I spoke for somebody's philosophy of religion class today on that issue.
Oh, okay.
Which is other work I'm doing.
Right.
That's what I'm out here in the spring in the Los Angeles area for, at the Center for Christian Thought.
Okay, thanks.
Okay, this will be the last question.
Thanks so much for
Right.
being here. I think I wanted to pose the question that's the hardest for me to deal with in all of this, which is, I think your argument's persuasive, but what about the argument that only in a universe that is this finely tuned could we be here in a form that could observe the fine-tuning?
Okay, that's what the multiverse hypothesis tries to do, right? It says there's many, many universes, and we could only arise in a universe that was just right for us. So it's no miracle that when we look back, it's fine-tuned. It's called...
Necessarily.
But it's observer selection effect is being appealed to there. Well, that's one problem. I'll take two problems with that. And that is, I think, the biggest challenge to the argument. The one problem I already went over. It's vastly, vastly more likely that an observer would be a Boltzmann brain, an isolated observer, than it is beings in a world that we can morally interact, help each other, and make moral choices. So that's one huge problem with that position, the Boltzmann brain problem. Another one, and this is where it very much excites me about the fine-tuning for discoverability. We could have existed in a universe that was vastly less discoverable. And you can move the constants around. We could exist in a universe that you couldn't get beyond the Stone Age because you couldn't build open wood fires. That microscopes did not have the resolving power they do. They have far less. In which a host of other factors weren't right for the development of science and technology. So when you bring that in, a fine-tuning for not only life, our kind of life, but that we can actually come to know about the universe, discover its structure, then you get something beyond any ability of an observer selection effect to account for.
Okay, we have one more brief set of announcements, I believe from Chad Markson, but before that, please let's thank Professor Collins one more time.
For more information about the Veritas Forum, including additional recordings and a calendar of upcoming events, please visit our website at veritas.org.